Absolutely true. Still true. Will always be true. I should maybe have some caffeine, be hydrated, well nourished, all this stuff in order to have the energy to exercise. But it's also true that exercise gives us energy. And most all of the studies that have explored the relationship between exercise, brain health, and longevity and performance find positive effects. Now, for some of you who are skeptics, you might be thinking, well, great, so you can do any form of exercise? Well, in some sense, yes. I'll actually tell you this right off the bat. There are good data showing that if people do 6-second sprints, max all-out sprints on a stationary bicycle, followed by 1 minute rest, and repeat that 6 times, you see significant acute effects on brain performance. So the brain performance could be a memory task. Sometimes it is a memory task. It could be what's called a Stroop task, which is a cognitive flexibility task where you have to distinguish between the colors that words are written in and the content of the words. Okay, so-called Stroop task. I've talked about this on previous podcasts. I'll talk about it a little bit more later. Regardless of the cognitive test that's used, that very short duration, high intensity training increases performance significantly. As well, 20 or 30 minutes of so-called steady state cardio, figuring out how fast you can run or row or swim or stationary bike for 20 to 30 minutes at a steady state. And then you analyze people's cognitive performance on a memory task. Can be a working memory task, so remembering a short string of numbers, or it could be math problems. It could be the Stroop task. Any number of different tasks reveal the same thing, which is that the longer duration, lower intensity cardio also significantly improves performance. Now, does that mean that you can do 6 rounds of 6 seconds of sprinting with a minute in between, or 20 minutes of cardiovascular exercise and get the same effect on brain performance? Well, if you're just looking at overall improvements in performance, so for instance, the percentage of information that you learn if you do or you don't do the exercise, or if you compare those 2 forms of exercise that I just mentioned, in that sense, yes, it really doesn't make a difference, which may have you scratching your head, but in a few moments, I'll explain why that is. On the other hand, different forms of exercise, of course, impact our bodily health differently. Higher intensity, shorter duration exercise, of course, impacts things like VO2 max and which circulating hormones and neuromodulators are going to be present very differently than longer duration, lower intensity exercise. So too, if you have people do single joint isolation resistance training exercises, like a single leg extension or both legs leg extension versus 10 sets of 10 in a squat exercise, you're going to see very different specific adaptations at the physical level, at the bodily level. But in every case where you explore the acute, the immediate changes that occur in brain output and function after people do that sort of exercise, you're going to see significant increases. When one does physical exercise, short duration, high intensity, cardio, or higher intensity resistance training, single joint training, compound training, single joint isolation exercises, compound exercises, one sees these increases in brain performance, at least acutely, in the immediate stage after the training. So we have to ask ourselves, why is it, how is it that all these different forms of exercise are positively impacting brain performance? And the answer is very simple and fortunately gives us tremendous leverage over our exercise and how to impact our brain health. And the answer is arousal. However, the answer isn't entirely arousal, meaning not all of the positive effects of exercise on brain health, longevity, and performance can be explained by arousal. But when I step back from the literature, again, an enormous literature, tens of thousands of peer-reviewed papers, many of which are done exceptionally well, by the way, as well as meta-analyses and reviews, I think it's fair to say that probably 60 to 70% of the effects of exercise on brain health, performance, and longevity can be explained by the specific shifts in our physiology, both bodily physiology and directly within the brain's physiology during those bouts of exercise, which is this increase in so-called autonomic arousal, which occurs during the exercise, but also extends into a window after the exercise is completed. Absolutely true, still true, will always be true. I should maybe have some caffeine, be hydrated, well nourished, all this stuff in order to have the energy to exercise. But it's also true that exercise gives us energy. And this is how it gives us energy. When we move our body, the adrenals release adrenaline, and the adrenaline acts through two different so-called parallel pathways within the body, but again, it doesn't cross the blood-brain barrier, so then there's a series of what we call signaling relays or circuit relays up to the locus ceruleus, and then a sort of analog. It's different, but an analog to epinephrine, norepinephrine, is released within the brain, and lo and behold, we have elevated levels of both bodily energy and brain energy and focus that we can devote to that exercise, but also to the learning that comes after that exercise, which explains pretty much everything that we've talked about up until now during the course of this podcast. So the next time you're feeling a little tired and you don't want to work out, remember, exercise gives you energy through the pathways that I just described. It's a loop, okay? The adrenals release adrenaline. They do these things by these two parallel pathways I've been talking about. But your decision to engage these motor areas, to move particular areas of your body, is what deploys that adrenaline. Now, you might be thinking, well, duh, okay, when I exercise, there's adrenaline release. In order to exercise, I need to move my body, and these brain areas control the movement of my body. But it's not a duh. It's actually very profound because it turns out that the specific brain areas that best activate the adrenals are the brain areas that control the muscles closest to the midline, the core musculature, and the brain areas that are involved in generating the sorts of movements that we would call compound movements, at least in the context of resistance training, or that are responsible for moving multiple joints at the same time. So what this means in the practical sense is if you are feeling sluggish, you want energy, or you're simply exercising both for bodily effects and for brain effects, you need the deployment of adrenaline, of epinephrine. You need the deployment of norepinephrine in the brain. And by the way, anytime you have a deployment of norepinephrine in the brain, almost always there's a coordinated action of release of dopamine, which most people have heard of by now. Dopamine is involved in motivation as well as movement, etc. So the simple takeaway here is if you want to get the arousal that comes from exercise in order to use that arousal, to leverage it towards better cognition, brain health, etc., the key thing is to make sure that you're doing exercises that are compound exercises. So that these would be the movements. You can look these up, just say compound exercises. You can put that anywhere and you'll see that that includes things like squats, deadlifts, bench presses, dips, pull-ups, rows. And yes, of course, you want to train your whole body so that you have, symmetry of function, of strength, and you want to offset any injuries and things of that sort, or aesthetic reasons, perhaps. But the idea here is if you want energy from exercise, you want focus, you need the deployment of the neurochemicals that we've been discussing, most notably epinephrine and norepinephrine. And through the identification of this motor network, as well as the affective and cognitive networks that converge on this area of the spinal cord and then send communication to the adrenal medulla, you can essentially control the levels of arousal that your body and brain produces. So in describing this, my hope is that you'll no longer think about exercise as just elevating your heart rate, or you no longer think about exercise just as moving your body, but rather that the movement of your body is creating specific neurochemical outcomes, both in the body and the brain, that create the arousal that initiates the improvements in focus and attention that allow you to learn better and that contribute generally to brain health and longevity. And this is one of the tools that I find particularly useful anytime I want to overcome that wall of kind of resistance to not doing the physical exercise that I know I and basically all of us should be doing.
Thanks for watching. If you found this information helpful, be sure to like, share, and subscribe for more health and wellness tips.